So guys, in this we are going to learn the coding part of Huffman coding. And let's go through the code now. And we have included in this slide we have included all the standard libraries, and we have defined a max tree ht with the value 100, and we have used two structures and their names are min heap node and min heap. And the structure min heap node includes the character, the data character, and frequency which is unsigned. And over here left and right childs of this struct node is declared with star left and star right. And in the second structure declaration min heap, you can see the size which is unsigned and the capacity unsigned, and an array min heap node array which is declared in the structure. And in this structure min heap node takes the parameters data and frequency. In this structure the left and right is declared as null, and the temp of data is given the data and the frequency is assigned with the frequency, and we are going to return the temp. And the structure min heap, we are going to pass the parameter capacity. Struct min heap is declared, we are dynamically allocating the memory for them, and the current size is declared 0, and the min heap capacity is assigned with the capacity, and the array is dynamically allocated and the capacity star size of struct min heap node, and we are going to return the min heap. In this slide we are going to go up with two functions. One is swapping and other one is finding the minimum. And the swapping function, we are going to swap the minimum heap nodes, and in minimum heap function we are going to find out the minimum value and then arrange them in the order. As I said in the last video, we are going to arrange them in the order and then add them and place the value to the corresponding places. This is what happens in this function. This function is used for performing this particular operation. In this slide we are going to deal with two functions. One is the size function and other is the minimum value function. In the size function we are going to return whether the heap is 1 or not, and in the minimum value function, we are going to extract the minimum values and return the temporary value. In this slide we are going to deal with two functions, that is the function to insert a new node to the minimum heap and the function to build a minimum heap. And inserting, we are going to increment the heap size, and int I we are going to assign minimum heap minus size minus 1 while loop. In that while loop we are assigning minimum heap of array of I is equals to minimum heap of array of I minus 1 divided by 2, and I is I minus 1 divided by 2, and so on. And void build minimum heap, structure minimum heap star minimum heap. Here we are declaring n I and a for loop, and n is with minimum heap. And finally we are going to call a minimum heap heapify function which takes the parameter minimum heap and I. In this particular slide we are going to deal with three functions, which is printing of an array, and the second one is finding the leaf node, and the third one is we are going to find the heap, whether it is equal to the capacity or not, size of the heap. And in print function we are going to print the array whatever we have got, that is for the particular characters will print the array. And the utility function, and the second one utility function is going to check if this node is a leaf or not, whether a leaf node, and what is the array for that we are going to check it in this function. And then the third function creates a minimum heap of capacity equal size and inserts all the characters of data in minimum heap, and we are going to insert all the characters into the heap and initialize the size of the minimum heap is equal to the capacity. And we are going to call a function in this inside build minimum heap, which takes the parameters as minimum heap, and we are going to return the minimum heap over here. And this slide deals with the main function through which we are going to build the Huffman tree. In the step 1 we are going to create a minimum heap of capacity equal to size. Initially there are modes equal to the size, and in the second step we are going to iterate the while size of heap doesn't become 1. And the step 2, exact the two minimum frequency items having minimum heap. And the step 3, creates a new internal node with frequency equal to the sum of two nodes frequency and make the two exacted nodes as left and right children of these nodes. And step 4, the remaining node is the root node and the tree is complete. And now we are ready with the Huffman tree. In this slide, we are going to print the Huffman code from the root of the Huffman tree. It uses array to store codes, and we are going to store the codes in a particular array. And this code deals with this. In the first if loop, we are going to assign 0 to the left edge and recur. As I said in the explanation of the Huffman tree and the construction, I've gone through like the left side, whatever the values which will be present in the left side will be represented by 0 and the right one will be represented by 1. This is what being takes place over there, assigning 1 to the right edge, and we are going to perform the recursion operation. If this is a leaf node, then it contains one of the input character and prints and this code from the array. Yeah. And after printing the Huffman code, we are going to print the Huffman codes and the tree. The Huffman tree is built perfectly now, and in the main program we are going to pass the inputs. These are the raw data which are going to pass. We are not taking the input at that particular instance. We are going to give the input through the program, and my input to this program is A, B, C, D, E, F with their frequencies 5, 9, 12, 13, 16, 45. So A is assigned with frequency 5, B with 9, and C with 12, and D with 13, E with 16, and F with 45. And I'm going to call a function Huffman codes through which I'm passing the parameters array, frequency, and size. I'm going to return 0 here. And finally, we are through the end of the coding, and this is my output. And for the characters F, the code which is generated through the Huffman coding is 0, C 100, D 101, A 1100, and B 1101, and E 111. We are done with the entire algorithm, and thank you guys.